When it comes to risk management of medical devices, we talk a lot about safety. But what about reliability? I've often heard from people that reliability and safety are two sides of the same coin. So, how are they related? Well, we're going to explore this question today with my guest, Mitra Soltani. Hi, everyone. I'm Naveen Agarwal, and I want to welcome all of you to this special episode of the Let's Talk Risk podcast. Now, Mitra is an electrical and electronics engineer by training, and she has had many years of industry experience in design roles, designing, developing, testing, integrating hardware, software, all aspects of development for electromechanical medical devices. So she has seen both sides. She has seen the safety side and the reliability side. And I'm hoping for a great conversation on this topic. So, with that, Mitra, welcome to the show. How are you today?
Hi, Dr. Naveen. Thank you. I'm doing well. Thank you for inviting me and having me for the podcast.
Wonderful. So, Mitra, why don't we have you start by sharing very briefly your career journey so far? What got you interested in electrical engineering and then later on a career in the medical device industry?
I started to inventing a few things in electrical devices, and that's put me to the journey of being an electrical engineer. And then by maybe luck or chance, I started in the medical device, and since then I am in the medical devices. And sometime been a few years right now that also I am in the defense industry as well. So that being said, putting like I think over 15 years of my career being in medical device and thinking about how to design a good, reliable, and safe for the patients. And it's not always about what regulations gonna tell us, because when it
Mhm.
comes to the defense and medical, the first thing that comes in the mind is that, oh, we need to pass a lot of regulations, but at the end of the day,
Yeah.
no, we need to be safe for patients, the people that they are a user at the end of the case. And that's been in my journey and my mindset in my job. Right now, I am a consultant for startups, and usually startups calling me when they want to scale from prototyping or 5 unit to 25, or when the actual
Mhm.
reliability cracks hits. And I also am a part of Johnson Johnson's working with them in the reliability and the test strategies.
Okay, wonderful. Now we're going to talk about reliability and safety in just a moment. But Mitra, I'm so fascinated by a passion project that you do. It's called Superstars for Tomorrow. Can you tell us a little bit about how you started with this and what you're hoping to accomplish?
Right. So our project is Superstars of Tomorrow is about teaching young adult leaderships, creativity, and finance, right? And how it's started is because I'm consultant going through different clients and seeing so many people technically very strong, technically capable, and they are very good engineers, but when it comes to the communication, leadership, they are lacking. So they are strong, but when it comes to the financials, the easiest one, the simplest one, they are struggling.
Mhm.
And then also the creativity. And when you come bringing all three of these aspects together, you could have a better future. So as a mom, I am a mom and twins, and twin daughter. I have twin daughters, and I thought that if we were able to teach our children from early stages, from teenagers to young adults, from 13 to 24, when their mind is building and shaping, and we could put that mindset in their mind that you could be successful, you could be anyone, and no AI could take these skills out from you.
Mhm.
Is like when you can lead and influence in the community in positive way, when you can take control of your finance, and when you can be thinking creatively. And that's why I started the passion projects that you're talking about, the Superstars of Tomorrow, and trying to teach the young adults how to start better.
That's just incredible. Thank you so much for sharing this with us, and I wish you all the best.
Thank you. I really appreciate that.
Okay, great. Now, so let's talk about safety and reliability and how they are connected to each other. Now, we understand safety a lot and we have a lot of focus when we talk about risk management of medical devices. When we say when the benefits outweigh the residual risk, then the device is considered to be safe. How does reliability play into this whole equation? Help us understand.
So the reality is that the reliable device is a safe device. So reliability comes first, then it comes safety. At the end of the day, when it comes to the reliability, it comes to that when you want to use any devices, you need to be able to make sure in all use case of environment your device work consistent and does not have unpredictable error or failure. So if your device fails 1 out of 100 times, right, you think it is good. But if that one time it is in the middle of surgery, or when the parents is using it for their children or reading it and it's wrong, you are bringing harm. And that comes reliability. And if you're reliable and if you can pinpoint the issues and traceability and analysis and human factor for it, then you are safe and you can provide your risk management that it says, okay, you maybe need to bring down your circle of users lower, so to make sure that the 1% will be out of your circle, but then your device is reliable and your reputation is high, you don't have recall.
So it seems to me that there's a connection to requirements here. We had to ask the question, reliable for what? That means we have to establish requirements, and those requirements should be, I'm guessing, complete enough to make sure that we also deliver safety. Am I reading that right?
That is correct. So it comes to the design inputs, right? So what are our design inputs and outputs? First, what is our desired outcome for the device? What we want our device, what is the functionality, what is the features, and what is the environment that they want to work in, right? So all three of them is just kind of what it comes to the input design, right? Within that input design, we need to have assumptions registered. What are our assumptions about this device? What is our out of a scope of the reliability and risk of this device? And then right next to it, how we can trace and what is our key risks in this device and how we can play it safe. That's when it comes to the very minimal and the beginning stage of it. Just write down at the beginning as an input design, and then of course we can explain about in a different layer of it and just how it gets cooked all the way to the end when it gets ready for production.
You mentioned assumption register. This is very interesting to me because I've never heard this before. Say a little bit more about how it works and how you can put that in practice.
So when as an engineers, people are starting to product using a design for a product and or engineering it, there are different layers. But at the very beginning, when the idea coming and I want to, I don't know, make handheld device that is going to be used in home environment, but is a medical device. And we wanted to introduce that device. As an engineer, when it comes to my mind that this needed to be done, we have the assumptions. Hey, we need this to be used in X and Y and Z conditions. And this is our assumption that if you use it in these three conditions, it will work fine, right? But that is the assumption, that is the assumption register. And you also make sure that you have assumption as much as possible about your design and your idea. The idea, it is completely different than what actually goes to the design inputs, completely different, but it is linked with your assumption. Your risk is connected to your assumption, because even at the beginning, you didn't think that this is going to work under the humid environment, maybe. That wasn't your assumption. You were like, I am thinking about the device in a very dry environment. So put that there. So when later on, the device you are making, and that is not part of your assumption, you're making it as a just handheld, and nobody said it is a dry environment or humid environment. You just handheld device, and then later on making it, when it comes to the risk factor, say that where does it work and where does not work. You can go back to your risk as I said that, well, when we assumed that it should work in dry places, but we didn't test it in humid places, let's test it. Maybe it works. Then you're good to go in the different, but your assumption wasn't dry.
I'm really fascinated by this concept and it makes so much sense to me because we make so many assumptions and most of the time they are in our heads and we are not even aware of those assumptions. And it's very important for us to write them down as a assumption register, link them to the risk factors, link them to our verification validation plans and come back to them and revise them. And I'm thinking that this could also be a great tool for troubleshooting in the post-market phase.
That is true, but that is true, could be, but because when we get to the production, we are passing so many different levels. We are hoping in the MVP period, like a minimum viable product, we already put all of our assumption to our risk documentation. So it's already changed to that point. So that is our risk documentation that goes to our QMS tools, and then we can use the traceability. So it doesn't back to the assumption, because assumption doesn't have the traceability. It's just what we taught at the beginning, but we linked it later on in the risk, and we tested. We test with what was your assumption was, and what is this? Is that passing, or is that better than what you think, or is that less than what you thought?
Oh, this is fascinating. Thank you for sharing with me, because I had not thought about this before. It makes so much sense to me. Great.
Oh,
Yeah. So let's talk about the small startup environment. Things are happening fast. Everybody's trying to do so many different things. And when you start to talk about reliability and safety, what are some of the common challenges that you come across?
I think the first thing that think about reliability, it is hard, it is expensive, it takes too long. That is what the mindset of the startups mostly they are, when it comes to the people, that they are not prepared. If you didn't think about reliability at the very beginning stage, and it comes to the end of it, and you want to just push to the market, and then you need to have a submission to the FDA, and you put the form in front of you and figure out that you don't have any traceability and any risk control, any design review done correctly, then you have to redo all of this. It's time consuming, it is very expensive, and it is very hard. Right. Why I'm mentioning this, because when it comes to the startup, people only thinking about minimum viable products on functionality and features, because they want to get their investors. They want to get what the investors seeing it as a function and features for the early stage we are talking about, right? So that's that mindset. It comes to be sometimes very expensive, because when they only think about features and function, and they're just engineering it quickly to just show that the prototype works. Yes, the prototype works, but it's not reliable. We all know that as an engineer, if you do a prototype, from prototype to production, there's a lot of way to get to that, a lot of testing you need to do, a lot of verification and validation you need to do to get that. And a startup tends to shortcut that to be quicker, and that's where the reliability become an issue.
Yeah, yeah. And I can understand the environment that they're operating, because funding is tight and they have to get the next round of funding by showing progress. So in this environment, can you share how best to communicate this idea to decision makers, and also help them think of it as more like a project plan, and not necessarily just going from point A to point B without any other steps in between? How do you best communicate that to the senior leaders?
Exactly. So I think, first of all, it should come from top to bottom, right? The leader should be very well aware of that especially any startup, but especially when it comes to medtech or defense, you need to have a safe and reliable product. It doesn't matter if it is in the prototyping or the production level. The very first thing you need to think about that, could you operate 100%? In a zero phase failure. We say 100% never is 100%, but we aiming for 100%, right? But the question comes to the point that in early stage, we don't say that you go and get the best and most sophisticated and most expensive QMS, but we ask for well-organized confluence with the risk analysis and log connected to it. We ask for the reliability engineers be part of your team, or have somebody part-time come and re-look at your map and be part of your design review. So at the very early stage, you can pinpoint all of the risks and managing all the traceability. And one of the other more effective way they could do, they have their design teams, and usually they are very small. They are very talented, but if they didn't work with each other before, or they didn't work all in the same type of industry, the way of their thinking and the way of designing, they are different. How about you have a training, a reliability training, right, for them at the early stage, that they talk about how to use the QMS and what to use in your design and how to use it at the very beginning. And you can done this training easily. I could help that. There are a lot of people who could help that. You do training within a 1 hour or two in combination of maybe bigger one but your teams now is ready. Your
Mhm.
systems is ready. Nobody's in behind, and nobody is in a roadblock, and can move forward faster,
Mhm.
quicker, and more reliable.
Yeah, because I know that nobody wants to build a product that is going to be unreliable. I think
That's true.
intentionally nobody wants to do that. So it's a question of awareness and bringing this into focus and top of mind so that you can plan for it. And what I'm hearing you say is that by doing this training early on, you make your team aware and prepare them for success and not surprises down the line. It doesn't have to be very expensive. It doesn't have to take too long, as you mentioned, but it's a matter of prioritizing your team and preparing them for success. Well, excellent. Now, as you look back on your career, can you share with us one example of where you have seen this work out really well? How they were able to actually manage time, budget, and everything, all these priorities, so that they could go to market with a very reliable and safe product.
That definitely I could bring down to the very specific example that I was fortunate to be part of it. So it was in a startup company that I was part of the team from the time that they were ready to scale from 5 units to 50 units. And although we've been through all of the traceability and reliability, and since I was part of the team, I was kind of knowing all the design review, all of the parts that I was just a consultant. I was just coming back and forth. At the end, I suggested to them that let me test the reliability, let me run the halt test. I know it's a destructive test, but let me do a halt test for you guys and let me go through the more specific and rigorous testing and see that we are ready for production and going. And we did test, everything was good, but one thing, one of the connectors was getting loose when we went to the thermal cycling. It was getting loose, but it didn't fall down. It was just dropping voltage.
Mm-hmm.
Sometime once a while dropping voltage, and that would have caused that the system not working, but not knowing why, because you don't see it, you don't figuring it out if you didn't put all the time and energy to it. And could you imagine putting all these things in the production level, and one connector would be the reason that you could have a recall? They are a startup, so the investor would have lose all the hope and the faith on them, and the reputation would have been ruined just for something. And we caught it early. We were very proud of what we did, and they were very happy.
I'm very curious. Did they figure out why it was happening so that we go all the way to the underlying drivers? And part of it is technology, but part of it is also our design process, our methods, the way we manage project. Could you share some details of that?
Yes, definitely. So this connector would have been used only once or twice, right?
Mhm.
As when it comes to the reconnecting, you connect the cable and that will be set and it's not going to move anytime after that. It wasn't user connectors. It wasn't like back and forth. So because it was not user connector, they did not add any safety pin to that connector in the design review. So there any latch to hold it down and adding any safety part. And that being said, when it comes to the testing, and it was a stress testing and using it in a high thermal situation over and over, we will see that, okay, now it's failing just because the
Mhm.
pin is not, it's loose. So it comes all the way back to the designing correctly. Again, come back to your point, nobody trying to design something that does not work, right?
Mhm.
But not everybody aware of the use cases and environment and the stress and all the type of usage that the user gonna put
Mhm.
this device going through, right? So you're designing it in one type of mindset, user using it in different type of mindset, and
Yeah.
come out completely crashing with what you were thinking. And that's when the reliability, you need to think it a little bit wider. That's when all the tests coming, that we testing it to the point that, okay, in all the different environment if you're being used, you are still reliable and you're not having a
Mhm.
failure.
I think this ties way back to what we were discussing before about the assumption register. To me, if we are not very familiar with the use environment or the different use cases, we may make some assumptions that actually may affect our design decisions and then that may affect the reliability of the product in use. And it's only through those conversations happening early in the design and development phase that we broaden our understanding. And that's
That's
where we
correct.
can challenge our assumptions, we can refine our assumptions, and we can make the right design decision. So I see a very big connecting point with the assumption register that you just talked about. And I encourage people to take it as a learning opportunity and not necessarily, assigning blame or pointing fingers, somebody did not do their job or something like that. Nobody wants to do it intentionally. But if we are all together as a team more aware, and to your point, if we are trained early on and have awareness about this, then it goes a long way. One of my guests in this program shared with me that normally we design for the happy case and pray that everything goes well. That is not how you can launch devices which are reliable. In fact, we have to be a little bit more conservative and aggressive during the design phase so we make sure that we are not assuming things that are not going to be true in the future. So this is fascinating. And of course, we could talk about this topic for a long time. But Mitra, I want to shift gears a little bit and really ask you to reflect on your career journey so far. What stands out to you in terms of real key pivotal moments in your career history that have shaped your career trajectory and where you are today? Can you share a few of those examples with us?
I think when it comes to my career journey, there are a few segments that I figure out that I need to rebrand myself and rethink myself and put out my roadmap as a career and where I want to be and where I want to go. And that's when, at the beginning, when I came to United States, what I could think of that I am a technical person, I am a problem solver, and I want to be part of this journey. And when I started, it occurred to me that I could help more than only a technical solving. I could actually communicate and make the understanding between inputs and outputs right in the real world. And that's where I started to think that, okay, I want to be able to help people. I want to be able to be a person that not only technically strong, but be able to communicate well with all the top level to the bottom level. When we're talking about CEOs and all the way to engineers and the colleagues and the technicians. So when we go through all of these things, I realized that I need to rebrand myself as a person that could help. So I started to have an intern and I started to taking more intern and having people. I started to teaching the intern, teaching them to how to move forward, and that become another pivot point of my life. And I started for when I'm talking about superstars of tomorrow. Also, it's just comes to I understand that teaching other people, helping them understand, it makes me happy, makes my journey more valuable. And I choose medtech because I want to see what I work. It actually helps people. It make the life of the people better. And that's another part that it comes to the reliability that I want to make something for sure reliable, for sure safe. When it comes to reliability, for me, reliability and safety is almost the same. I know they are different, but for me to have a safe device when in a most needed time when you are sick.
Yeah.
Right?
When you can count on it.
When count on it, it is important. And that's how it shaped my career to become who I am today.
That's fantastic. Thank you for sharing that with us. Now, as we close, do you have any suggestions or recommendations for QA/RA professionals or engineers in our industry who might be like, at early phase of their career progression? What are maybe top 2 or 3 things that you can recommend to them that they should keep in mind for their career advancement?
So make your decision early. It doesn't matter it is right or wrong. You don't need to make sure that the decision you're making it is correct one. Just make a decision, but make it early. Think later, act on it, think through it, the decision that you made, and be strong about that. Believe me, after a while, if that wasn't the one, you gain the experience that if you would have choose the other one, you are right now in a shortcut of the second option that you had. If you don't make a decision, if you do not act, and when you act, you do not think correctly and persuasively, making sure that you improve on that, you will be behind. So my suggestion is to all the engineers moving forward is that just make your decision, be clear about it, and act on it successfully. If that's not the good one, You already made a short form for the new one. I'm pretty
Mhm.
sure about that.
You learned something along the way. And just to clarify, when you say make a decision, you're talking about what you want to do with your career, where you want to be, right?
Correct.
So yeah, be decisive and take the action. And if it doesn't pan out, you would have learned. And in fact, I can relate to that. You know, what I'm doing today, I would not have imagined 10 years ago.
Right.
And it allows me to have conversations with such accomplished professionals like you and get to know them. So what a way to close. I really appreciate that. And as we close, do you have maybe a couple of closing comments that we can take away with today?
Thank you, not only because inviting me, because you are the person that make me actually think about the community that you are making more and more, and looking through all of your resources that you're providing. It is very valuable. And I really like that, and I really enjoy that. And I'm trying to getting better in the community, being more available in community. And what I want to say, beside the thanks to you, I want to thank anybody, everybody that in my career helped me to get to where I am right now.
Wonderful. Thank you so much for sharing your insights with us today, Mitra. I wish you all the best in your career and in your project, Superstars of Tomorrow. It's such a worthy project, and I wish you all success ahead.
Thank you. I really appreciate it.
Okay. Once